I'm going to show you guys how to calculate efficiency. So I'm taking some data from an old class. And what they did was they dropped their mass out the window using their rubber band cord, and they recorded how high it was off the ground when they did that. So let's do some basics. Here is a quick diagram. It looked like this. Here's the egg. We've got our initial height, which is 12.49 meters. Okay, here's the courtyard. It went down, and I checked their data. It went down to a height of 1.5. So here's their H2 equals 1.5 meters. The other stuff that I got from their data was that the mass that they used on that day was 57.5 grams, and of course the SI unit for mass is kilograms, so I wrote that as kilograms. The length of their cord is 7.5 meters. They used 9.81 as their value for G instead of 10. And the K of their cord, which they measured themselves, was 0.8 newtons per meter. So what we're going to do is we're going to go through the efficiency calculations. So we do little e times E1 is equal to E2. And we solve for little e, which just means that little e is equal to E2 divided by E1. So the total energy up top is E1, the total energy down here is E2. Now, before we get started with this, there's a few things we have to do. So the very first thing is that you have to set a reference height of 0 right at the bottom of where the egg is. So instead of H2 being 1.5, H2 is going to be 0, which means that we're going to subtract 1.5 from here to get our new H1, which will be 10.99 meters. So I'm not going to use 12.49, and I'm not going to use 1.5. I'm going to use 0 and 10.99. When I look at this diagram, the only thing the egg has at the very beginning is GPE up at the top. And down here, now that we set this reference height to 0, this is the bottom of the drop, so it's about to bounce back up. So it does not have KE, it does not have GPE, but it does have EPE. So basically, the GPE at the top is E1, and the EPE at the bottom is E2. Okay, a couple more things we have to do. So we already know that this thing dropped 10.99 meters. So if our cord length is 7.5 meters, that means that it stretched an extra 3.49 meters. So that's the stretch we're going to use here. X2 is going to be 3.49 meters. So that's how we get ourselves set up. So this is actually the G of guide. Our unknown is our efficiency. And we're going to use the formulas, the following formulas. We're going to use GPE equals MGH. We're going to use EPE is 1/2 kx squared. And we're going to use that little e times E1 equals E2. All right, so from there, I'm just going to plug in and calculate things. So I'm going to do, I don't need a table. I basically just need GPE1 is equal to MGH1. That's going to be equal to our mass of 57.5 grams, which is 0.0575 kilograms. Remember, I said they used the more exact value of 9.81 for gravity, and then the height at 0.1 is now 10.99. And when you multiply those things together, you can see that. Yeah, you can see that. It's 0.0575 times 9.81 times 10.99. We get that is 6.199. I'm going to round it to that, but if you're using a graphing calculator like this, I suggest using, or your cell phone, just like store this in memory. So I'm going to hit this graphing calculator. You guys can't see it, but I'm going to hit, now you can see it, the store button, and I'm just going to hit this button here, which stores it as X. And then I have that exact value, so when I go back later to divide it, I can divide by that rather than divide by 6.199, sorry, that gives me a more exact answer. All right, so that's GPE 1. Now I'm going to do EPE 2. That's 1/2 KX2 squared. So the value that they got for K, now before I move on, the K, they got K because they got their chord. They built out to the length they wanted it to be. Then what they did was they figured out what stretch they had anticipated it going to, and then they gathered data. They stretched it to that distance that they thought it would stretch to, but they also got other values of data. So they set up a data table, right? And they did a very small value of K. They did a very large value of K. So, or sorry, not K, but X. So here we know it stretched 3.49 meters. I'm going to put that in there too. When they found K, they had anticipated it stretching more than 3.49. But let's say they anticipated it stretching 3.49. Their smallest value of stretch that they should have tested should be 0.349, which is about 35 centimeters. And then they eventually, the last stretch they stretch it would be 3.49 meters. So and then they found the slope of the line of best fit. So that's where that 0.8 comes from. You got to be as exact as you can be finding that line of best fit. Be very careful when you take your data. Okay, so I'm solving for this. So let's see, 3.49 squared. Oops. Great. Okay. 3.49 times 3.49. Great. Is 12, and then multiplied by 0.5, multiplied by 0.8. So I get that there is 4.87204 joules. Okay, so that's EPE2. And remember, up here, we have that little E, efficiency, times E1 equals E2. And all the way up at the top, we had written down that little e is going to be E2 divided by E1. So little e is going to be your EPE2 divided by GPE1. So I'm going to do that. E equals EPE2 over GPE1. So it's that 4.87204 divided by 6.199, which again, I saved that exact value in my calculator. So I've already got that 4.87204 up. I'm just going to hit divided by, and then I'll hit X, and I hit save that 6.119 in for X, and I get this number. So I get 0.7859. I'm just going to round it to there. Okay, so that's my efficiency. As a percentage, you just multiply it by 100, and that's your percentage. So it's 78.59% effective, which is pretty good. That means it only loses about 21%, 21.5% of its energy on the way down. So it should not, I might evaluate. Okay, this makes sense because energy is lost on the way down. You should not get a value of little e that is greater than 1, which means greater than 100%. That should not happen. So if you did that, then something is wrong. Most likely, either you read the video wrong for how high off the ground your cord was, you have the K wrong, or you just don't know how long your cord is. Maybe you measured this, like you got the stretch wrong. So if you get something more than 1, check with me because I can help you out. I hope this helps.